Okay, so what we're going to do is we're going to move this guy to here. Right, and when we move it to the center, it's going to be 4.4 times 10 to the 6th meters from this guy, and 4.4 times 10 to the 6th meters. You got to figure that out, right? You got to figure that out, that you would be there. Okay, so what we're going to do is we're actually going to, since this is the mass that we're moving, we're going to do this. I'll call this guy A, right? We'll do this. We'll call this guy B. 9.7 E24, right? And then we'll just find the potential here and the potential here, okay? This will be my initial potential, and these are their gravitational potentials, right? This will be my final potential, okay? So let's figure that out, right? So V, my initial one, is equal to minus G times 5.9 E24 divided by 6.2, because we start off 6.2 E6, right? Plus, and this is where it is, right? So minus G times 9.7 E24 divided by 2.6 E6. So let's figure that out. It's going to be a big number. Okay. Alpha F1 opposite of G times 5.9 E24 divided by 6.2 E6 plus, and then this guy here, opposite of G, whoops, forgot my fraction, opposite of G, hold on here, there we go, opposite of G times 9.7 E24, right, divided by 2.6 E6. 6.2, 2.6, be careful here. All right, okay, let's see. Okay, so are we ready for this? This is our initial, wow, that's just a big number. Wow, just not helping me here. Okay, so how about we go into scientific notation mode, and let's get the answer. That is negative 3.123 times 10 to the 8th joules per kilogram. All right. Whew. That's a lot of potential. All right. And then my final one is going to be exactly the same thing. So the opposite of G times 5.9 E24. But now we're going to be over the center. The center is 4.4 from each one, right? And then we're going to go opposite of G times this other guy, right? 9.7 E24. And then that's over 4.4. Notice that we're closer to this guy, right? Okay, so we'll be farther down in the hole. This guy makes a bigger hole, so this is definitely going to be a much more negative potential than the one we're about to calculate, right? Because there's a saddle in between this, right? And we'll be at the highest point of that saddle. Well, no, won't be the highest point. I don't know. We'll see. We'll see. Maybe I'll take back that prediction. Okay, so there's that guy. And now I'm going to do the same expression, but let's change these denominators and make them equal 4.4. Whoa. Okay, and the 4.4, by the way, came from what, 2.6 plus 6.2 is 8.8 divided by 2 is 4.4. That's where that came from. If you haven't figured that out yet, let's see. So this guy is negative, I was right. Okay, so negative 2.3648 E8. Okay, so moving this way actually got us from a deep hole to not such a deep hole. Okay, so now we can figure out the work. The work is m change in Vg, which is m V final minus V initial. So 15, this is our final, times negative 2.3648 minus negative 3.123. Okay, so 15 times this guy minus this guy. I'm so bad at this. Wow, that's like a lot. That's gigajoules. 1.137. So 1.14 times 10 to the 9th joules, and it's positive. Why is it positive? Because you're taking it from a deep hole here to a less deep spot in the hole. That's joules. All right.